Okay, this is problem 8 from lesson 112, and it wants us to find the middle term of this binomial expansion. We've been given a formula. This is the binomial theorem. It's a binomial theorem. So the binomial theorem, what that does for us is this thing right here can give us our coefficient. Where's my triangle? Here it is. Remember we were using this triangle? We didn't have to use binomial theorem because we had our triangle, and we would just grab the coefficient. We'd go, oh, it's something raised to the 8th power. The middle term would actually be, well, let's look on here. If this is raised to the 8th power, you'd go down and find the 8, and then you would find the middle term. Because, see, if it's raised to the 8th, it's going to have 9 terms, I think. Let's count. 1, 2, 4, 5, 6, 7, 8, 9. So if something is raised, like, to the 7th power, it'll have one more than, or n plus 1 terms. So this, if it's raised to the 7th, it has 8 terms. If it's raised to the 8th, it has 9 terms, if that makes any sense. If it's squared, it has 3 terms, right? So what we were doing is we were finding a coefficient. The 5th term, the middle term is this one right here. And so we find the coefficient, and then we would go like, so this thing right here gives us the coefficient without having to use one of these triangles. Why would I want to do it that way? The only reason I'd ever want to use this is if I had to create my own triangle and maybe it wanted like the 20th term. If it wanted, or not the 20th term, but if it wanted something raised to the 20th power, that would be bad, because even if I started with this, can you imagine how far I'd have to carry this out? So the binomial theorem, it comes in handy for big numbers. And even for this, if I didn't have this already made, if I had to start with 1 and make this on my own piece of paper, that would take some time. So it's actually faster to use binomial theorem. This part right here gives you these numbers, you know, the coefficients, okay? This gives you, well, let's do it the old way, and then I'll show you what each part gives you compared to how we used to do it. The way we used to do it is we want the middle term, so it's the 5th term, so it's going to have a 70. We'd go like this, 70. And then we know that this first part goes in descending order of the exponent. So in other words, if I call this F for first term, I actually usually call it capital A, but that would be confusing because this is a lowercase a. We'll just call this thing F, the first part. F would go like this. It would go F to the 8th, F to the 7th, F to the 6th, 5th, 4th, 3rd, squared, F to the 1, and then it would just disappear because it'd be F to the 0, right, this first part. And this part would go in ascending order. So this would be 2b, or negative 2b. This would be negative 2b to the 0, which means it wouldn't even show up at all because negative 2b to the 0 is just 1. And then be negative 2b, and then be negative 2b all squared, and to the 3rd, and to the 4th, and the 5th, and the 6th, and the 7th, and the last term would be to the 8th, right? Or hopefully you remember that. You've done that before. So that's what these two things are giving. This is giving me the first part, and this is giving, you know, like this part. This is giving me the second part. Okay, so let's do that. I know the first part, by the 5th term, it's going to be, let's see, it goes in descending order, so it's going to be to the 8th, 7th, 6th, 5th. It's going to be to the 4th power. So it's going to be a squared to the 4th. And we also know a little trick that we know that whatever this second part is, whatever that is, its exponent is going to, the two exponents will add up to 8. So I actually don't even have to count on this. I just know it's going to be 4 because this exponent plus this exponent is going to add up to 8. But I can show you also that it goes in, the F's go in ascending order. So it would be f to the 0, f to the 1, f squared, f cubed, f to the 4th. Sure enough. So, but we said, I said f, I meant s. It's going to be like that. Okay, and then if I simplify this, so it'll be 70a to the 8th, and then that's an 8, and then negative 2 to the 4th, 16 times 16b to the 4th. So 70 times 16 is 1120. That's how we used to do it, and that's very simple if you have this with you. But we got to learn how to use this binomial theorem. So binomial theorem, we should get the same answer. N is the number that your binomial is raised to. So in this case, it's going to be 8. So we can just plug the numbers in. And once you get these two numbers down here, you'll notice these numbers, all they are is what your first thing is getting raised to and what your second thing is getting raised to. It's going to be this should be a 4, and that should be a 4, and that should be a 4, and that should be a 4. Because you'll see. N minus k. Well, what's k? It's the middle term is the 5th term. So n minus k, so that's 8 minus 5. Should I write it all out? 8 minus 5 plus 1 factorial. K is 5 because it's the 5th term. Those should have both end up being 4s. And then, if you'll notice, this and this, they're the exact same amount, aren't they? So once you find out what this and this are, these are the same things. Okay? F we said was a squared. And this is going to be, can I just write a 4? Because 8 minus 5 plus 1 is 4. And then S is negative 2b. That's also the 4. We know those are 4s, right? Because we did our arithmetic. So, a to the 8th. Now this is that same thing that we just did over here. We had to take negative 2, I think it was 16b to the 4th. Okay, now the 8, well, we're just going to do some, I don't know, like fraction math. 8 times 7 times 6 times 5. I don't want to write 4, 3, 2, 1 because I want to cancel with one of these. But for this one, I got to write the 4, 3, 2, 1. And then, let's see, the 3 times 2 makes 6, and 4 goes into 8 twice, and 5 times 2 is 10, times 7 is 70. So now I have 70, a to the 8th, times 16, b to the 4th. Why am I doing this twice? Because I was showing you our old way, and now I'm showing us the new way. Well, we already know, we just did it. 70 times 116 is 1120. A to the 8th, b to the 4th. Now, I'll probably never know whether you used binomial. It didn't even tell you that you had to use binomial theorem for this. So it's okay if you want to do it the old way, the way with the triangle. I'm okay with that, but you need to know that this exists, because at some point you might get a number that's so big that it's not convenient to use your triangle, and then you need to know that there's this formula that can help you.